Hi everyone, and welcome back to the SolidWorks course. And this will be our last class. So I hope that you have learned a lot of about SolidWorks till this class. And by the end of the class, I hope you have learned something new about SolidWorks, or at least found the resources that I gave you useful for you to learn more about SolidWorks and continue your adventure with SolidWorks. So, going back to the course, we started at the beginning by creating 3D models from 2D technical drawings, then creating the 2D technical drawings from our 3D models that we designed ourselves. After that, we learned how we can create assemblies from the parts that we have created. And last time you saw this assembly that we created for a very basic, let's say, airplane landing gear. And after creating our part and our assembly, we would like to show our work or communicate our design to other people. For example, in your career or in our career, when someone would design something new, for it to be manufactured or for it to be reviewed, we need to somehow communicate our design to the others. So in this class, we will be seeing how we can communicate our designs with others. So first of all, in the last class, when we created this assembly, I already created the different parts and we just created the assembly. But as you might have noticed, the parts in my assembly in here are colored. And this was done via the appearance tab in here. This can be done in the assembly level, like in this mode, or if we right click on a part, we can open the part, and from here we can also edit appearance. And so if we left click on this, what this gives us is that it gives us an option to add an appearance or color to our part. So here we have the various options for the appearances for any part that you would like to have. This part had like a cast steel, I believe, color or texture. And so we could simply choose any of those options, and from here we'll be able to simply choose one of those colors and drag it to the part. What will this does is that for us, when we are designing, it will feel just that there is a difference in color. However, as we'll see later, in for example rendering, this will show a texture of whatever we created. So this will have a texture that is similar in the feel and look to a blue cotton. And so, for since this is like a metal part, we could choose any of the different parts. So let's say we take steel, and here we have the different types of steel: cast stainless steel, carbon steel, chain steel link, machined steel, and etc. So you could choose whatever you like, and you could just take it, drag it to the part, and you will have your appearance. You can then click OK, or if you just would like to change the color, you can also do that in here. So you can click OK, and with this, you have your new part with its appearance. So you can save it, and by hitting Control and Tab, you can go to the next window in your SolidWorks workspace. So with this, we have all the different parts. And so what we'll be doing, the first thing now is that we'll be trying to create an animation to show how this landing gear would work. And this can be used for any other mechanism that you might create to show how the mechanism work. So first of all, what we need to do is that we need to go to this tab, Motion Study. It's normally on by default. So we could create a new motion study, where in here we can create our animation. So what we are seeing here is that in here we see the different parts that we have in our 3D model. And those black and blue diamond shapes are called keyframes or just keys. And this is the timeline of our animation. So what we could do is that we could simply change something in our model, since in our model we removed some constraints for us to be able to move the part. Since if we keep the different mates as we did in the last time and we fully defined our model, we will not be able to create the animations, since every part will be fixed in position. So we need to at least remove a couple of mates so that we'll have the free movement of our mechanism that we would like to animate. So we could go to motion study. Normally it is always created when you create an assembly. Or you could simply right click on it and create a new motion study, or if you would like to create a simulation or a design study for any other applications. So in here, what you could do is that you could simply click on any keyframe. For example, let's say here at 3 seconds. And from here, you could move your part or your assembly. And what this will does is that it will make SolidWorks create a smooth transition from the first state until this. And we can see that by simply hitting this calculate button. So by clicking it, SolidWorks will create an animation, a smooth transition from the first state to the next state. And also with this, you could also move the camera and have SolidWorks pan the view as it creates this simulation or this animation. This can be done simply by right-clicking this orientation and camera views and deselecting the disable view key creation. Because with this selected, what happens is that when we move our camera, something like that, we move our we move to the next second, we move our part, and if we create our calculations, the original camera view will be repeated. So if we right click on this, deselect this, what will happen is that when we move, let's say we zoom in and we move to this view, what will happen is that we see this black bar, which is in the same line as this orientation. So we can know that this action would be done to this part. So, and when we move the wheels, we saw that this was created and those two links were created since the links were moving with the wheel. So now when we calculate our animation, what will happen is that as it is moving, the camera will also view, which can be used for creating various different animations. And with this, we could also use different features. Like in here, we have what is called an animation wizard. So if we left click on it, it gives us three options: rotate, model, explode, and collapse. And they are as their name suggests. So in this rotate model, it will simply rotate your model. So you can choose it, go to next. You can select which axis you would like to rotate on, number of rotations. Let's say you would like to have 3 rotations, clockwise, counterclockwise, next. And then you could also decide how long you want this animation to last. Let's say 5 seconds or 6 seconds. And when do you want it to start? So like last time we ended in the 4 seconds mark. So you could start it from this or you could change the time. So with this, we could simply click finish and SolidWorks will automatically create the views or the different key points or keyframes for it to create the animation. So we could click on calculate and we'll see the rotation of our part. And also we can see in here the explode and collapse, which will follow what we created last time. So if you remember from our last class, we created an exploded view of our part. And that exploded view that we created will be what will be shown in here. So we could also again choose how long we want it to last. This time, let's say 4 seconds. When do you want it to start? Let's say we don't want it to start when the rotation ends, but let's say during the rotation. So let's say we started at like 9 at the end of the rotation mode animation. So from here, we could simply click finish and you can see all the different key frames are created. So again, we could also, if we would like, since we could come in the end, we could change with Control 7 to the isometric view so that we can also create a change in the view. So again, we could go calculate. We can see how we started with the different first with the pan of the camera, the rotation, and after the rotation, we have the exploded view created and animated. So from here, we could also continue with the last one, which is the collapse. Next, we can choose the duration, let's say 5 seconds. We start after the exploded view is done, finish, and we can see here again the keyframes are created. We can again calculate and we can see how the animation for the collapse is created. So we could also, let's say, move our part to the end in here and zoom on it to have this point. And from here, we do not need to always move our parts by hand and then to calculate our animations. We could also use some features that SolidWorks provides us. Here we have a motor, spring, contact, gravity, and here we have extra properties. So in this class, we will just see this motor. So what this will does is that it will allow us to, so you can say, automatically control our part. So we will have a rotary motor where it will simply rotate some feature or some part, and the linear motor actuator for it to move some parts in one direction, one axis, forward or backwards, right or left. So in here, let's say this is a part of a landing gear, and there is some sort of a hydraulic that is connected to those links in this point. Or let's say in another design, there is a motor at this joint that will rotate the landing wheel when it is deployed. So we could simply choose rotary motor. We could choose this as the rotation. We can see the direction of rotation where it will be. We could simply choose on this, click on this one to change the direction, as you can see in here. So this is our direction. And here we have the different options. If we'd like to have a constant speed, if we would like to move some specific distance only, or if we would like to have like some data points that we create in a table and then SolidWorks will try to follow it. But for now, we could go simply with like constant speed. We can give a speed for a speed of, let's say, 1 RPM, and then we can click OK. And what SolidWorks will do normally is that it will start the motor from the beginning of the animation. But if we would like to, for example, start this rotation at the end, when we created everything, we could simply left click on this and drag it until the end. And then from here, we could go forward, let's say 1 second forward. And then what we could do is that we could simply right click off so that the motor will come off, and then we could simply turn it on in here. So here we can see the motor in this from second 19 until second 20. So here it's turned on, as you can see in this dialog box, with 1 RPM, constant speed, and then here it's off. So we could simply now, again, calculate the animation, and we can see what we have till now. So the different mode, first of all, how we can move and then change the keyframes. We can use the wizard, animation wizard for the rotation, exploding view or collapse view. And then we could also use the motor for it to start moving automatically. Or if we'd like, since it was a little bit slow and it didn't went far enough, we could simply increase the time or just increase the speed. So for the last time, we can have here how it's moving automatically with 1 RPM, revolution per minute. And so after we are done with all our animations for the different parts, what we could do is that we could simply go with save animation. And what this will give us is it will give us an option to save our file, our animation, any for a video format. So let's say MP4, we could choose our view. Let's say we can give a name to our animation. We can have a different here properties that we could create, frames per second. Let's say we would like to have 30 frames per second. We would like to have all that animation, not at sample time. We could change. We could also choose the aspect ratio and various options. So we could save. What will this give us is that it will give us an option to recalculate our animation before saving. So what it will do now is that it will calculate the animation for the last time before saving the video. So before, when we're creating any change, we would always recalculate to see our changes. But now after we are done with everything, what will happen is that with the calculation of this, it is calculating the different motions and the different animations for our model. And while calculating it, it is also saving it to that video file at the end. So after it calculates everything and saves everything, we will be able to later see our video format and we will be able to share it with others so that they can see what we did, how our design works, or how our mechanism works. And so for now, we could simply wait for it until it calculates everything, our 22 seconds long video. And after this, what we'll be seeing is that we will see how we can create, instead of videos, but we will be creating static pictures of our part. And that will show really the difference when we use the appearance that I talked about in the texture sense. So now our animation is coming to an end. So now once it's done, it calculated everything, and the video format will be saved in our computers so that we can later see. So if I stop the screen sharing right now and open that animation, we can see what we have right now. So the screen is loading. I believe now that you can see my screen, so we can simply start our animation and we can see how smooth it is and how the different operations we created. So we can also change the background theme if we would like to. We can again change the different colors and what we would like to have in our animation. So this will be useful for us to communicate how our design works. And so with this, we can go back to SolidWorks and continue with the next step. So if we would like to create now a static image instead of a video, what we can do is that we can go, first of all, if you see I have a new tab in here of Photo View 360, which will be the tool that we'll be using. To do that, we can go to Tools, Add-ins, and we can check on this Photo View 360 add-in. And this will give us the option to create renders of our part or assembly. So when that is enabled, you will have a new tab that is called Render Tools with all the different options in here. Again, it has the edit appearance and edit scene. So with this, we can simply change the scene. If we click on it, we'll go through what we have in this list. So we can choose whatever we would like. Let's go with this one, for instance. And so what we can do with this, a plain white might be better, to be honest. So from here, what we can do is that we can go with the normal view, and then those are the options that will allow us to create our picture. So there's first of all this integrated view. What will this does is that it will render our part and our view as we are in this mode. It can be used, for example, to preview, but it slows down the performance of your computer so much. So unless you have a very powerful computer, it is not recommended to use that. What you could use is that you could use this preview window. What will this does is that it will give you a window to preview how your render will look like, as the name suggests. So you can see here the view that I'm having in here. I'm not sure if you can see it, but to make sure. With this, you should be able to see this. So we have here my SolidWorks main view, and in here we have the preview window that shows a preview of the render for my part. So if, for example, if we here change the view, it changes in here. And if you zoom in here so much, you can see in here the different textures that are available with this. So you can see that in here it tries to give the different rubber texture, the aluminum texture, the different steel textures. If you go in here, for example, it also gives the different brushed texture of the different steels and tools used. So we can see in here that the top one was a cast stainless steel, while this one is polished. So you can see here the different textures that are given to the different materials. So it can gives a perspective of how the part will be, how the part will look if it is manufactured with the given part, with the given materials. And so with this, we can simply choose our view that we'd like to have our render in. So let's say something like that. We can also zoom in to make sure that everything is taking the full frame. And when it's done, we can save the preview image if you would like, or what we could do is that we could go to the final render, and this will simply create the rendering for our part in the view from what we saw in the preview window. So the preview window will be used just so that you can have an idea of how the part will look after it is rendered. And with this preview, with this final render, what it will do is that it will simply render your part. So depending on your options that you are using and the power of your computer, this might take long time. So first of all, the white background will be easy and like it can finish quickly, let's say a minute. But once it starts rendering more of the part and the different details, it will take a very long time. So for now, we could simply keep it running in the background so that later we can see our final result. And for now, we could simply try, we will continue with how we can communicate our assembly with other people. So we saw how we can create a video to describe our mechanism. We saw how we can create a render, and we are waiting for the render for our part to see how it will look if it's manufactured with the given materials. Lastly, we would see how we can create a 2D drawing for the assembly that shows the different parts in the assembly. So with this, we can simply go to File and make drawing from assembly. So if we create this, we can have our custom template, or we can have this, the template that we created last time in our classes. So with this, it opens, and from here, we can simply take the isometric view. And this rendering is so much computational intensive. It will massively slow your computer. So make sure that when you are rendering, you don't have something else working on your computer. So as you can see here, it's more slower than how it was with the background. And so for now, SolidWorks is somehow unresponsive. So for now, it's like 25% finished, and it will not allow us to continue our class. So I would simply abort it. But as you can see from this rendered part, you can see how it creates the rendering and how it looks after it will be rendered. So you can wait for it until it's rendered. But for now, so that we can continue, we will just simply abort it. So our speed came back to us. So from here, in our 2D drawings, at the beginning, we saw how we can create 2D drawings of the technical drawings of the single parts. But for an assembly, what we could do is that we can go with an isometric view of it, or we could go with the simply front, right, and top views. And let's say we'd like to have an isometric view. Let's take those a bit away. And let's now focus on this isometric view. Let's change the scale to, instead of 1 to 10, let's have it something bigger, 1 to 4, so that we can see it better. We can remove this view, delete it, and so this is our isometric view. So what we could do is that we could right-click on it and show in exploded state. And again, this will show it in how it is created when we created our exploded view in the assembly mode. So this is our exploded view. For now, I removed the different hardware, like the screws, the washers, and the nuts that we created. But you, when creating this, you can also, you need to add them. But for now, I removed it so that we can focus more on the different animation and rendering rather than trying to work with how the different hardware and mates will work with us. So from here, we can see our different parts in our assembly. And from here, we can go simply to insert tables, and we will have something called bill of materials, or what you will most commonly hear when you are working with other engineers, they simply call it BOMs, bill of material. So we can click on this, we can select our part, our assembly that we would like to create the BOM for. We can select it. For now, most of the time, the usual default will work, But later, if you get more advanced, you can create a template for this as well as we created with the different parts, creating drawing and assembly. So we can click on OK, and here we can see our parts, a table that has our parts. So we can put it anywhere in here, let's say in here. Let's move this away from here. And so with this, it shows us the different item numbers, part number or name. In this case, we could simply then edit it if you would like to from here, or we could directly go to the part and edit the different features in the part from there. So if, for example, we'd go to the wheel, if we control tab, we can go to the wheel, right click, open part wheel. What we have is that there is an option in here that allows us in the, I believe, evaluate. Right in here, right click on that part. And to be honest, I'm not sure where it is, but properties. Here we can go file properties, and from here we could also change the different summary, the different properties of the part. So when we saw in our bill of materials, there was one called description, and from here we could simply add a description. And by clicking OK, we can save it. And if you go in here, we can see the description updated. It also shows the different quantities. But what we could do also when we are creating drawings for assemblies, we can go to annotation and we can use balloons that before we were not able when we were creating drawings for only one part. So by clicking this, what this does is that it gives us the ability to be able to number the different parts. So we know that in our assembly we have a wheel, link 1 and link 2, but which one is it is. So like for now it's simple, it's clear, but in complex assemblies this will be essential. So you can simply click on whatever you would like to a number, left click, and then you can put this balloon somewhere that is clear, left click, and this gives the number. So this is one. So link 2 is number 4. I believe this is link 2. We can check. This is link 1. So this means this is link 2. We can put the balloon in here. And this is the wheel. So we can put something like this. And with this, we can have a view that shows the different parts in our assembly, how they are connected, and the different lists of parts or materials that are needed to create our assembly or our product. And with this, we have the three ways for showing our parts. First of all, this drawing part with the different components and the bill of materials or BOMs. Then we saw how we can create the animation, as we saw the first thing. And finally, we saw how we can create a render of the picture for this part so that we can feel how it will be textured, how it will look after creating it with the required materials. And so with this, the SolidWorks course for this SolidWorks course is done, and this will be the basics of SolidWorks. Like you can do way a lot with SolidWorks. You can do simulations if you'd like to. And there are various add-ins that can make SolidWorks even more powerful. And for example, if you open this part, you can see that in the tabs, we have very different tabs depending on what you would like to use. Surfaces, if you are more into surface modeling, surface swept, boss base, etc. Then we can also have sheet metal, structure system, weldments, mold making. You can also have simulations in here and analysis preparation if you'd like to do your simulations in SolidWorks, since it is one software and thus it will be compatible and it will be easy to use, to have at least a first view on how the part will be, instead of going to a different software to create your simulations. So from here, I hope you learned something new in this class again, and or at least I hope you learned new from the resources that I gave you in the SolidWorks syllabus from the YouTube channels or websites so that they can help you continue your career with SolidWorks to improve and gain more experience with SolidWorks. So for now, we are done. If you have any question, feel free to ask. If not, thank you for listening.